Welcome to the Lighthouse video series, where we dig into the technologies that Nichols Portland Inc. offers to our customers in the market and dig into how our customers can use those technologies to their maximum benefit. I'm Stephen Medill. I'm the Executive Vice President of Sales and Marketing for Nichols Portland Inc. Today I have with me Tom Freemer, our Plant Manager for our MIM facility, and Jason Osborne, our VP of Advanced Engineering. Today we come to you from the Center of Excellence that's located at our Alpha Precision Group facility in Ridgeway, Pennsylvania. And this facility is focused on the metal injection molding technology as well as our 3D printing or additive manufacturing. So gentlemen, thank you for joining me. Today we're going to talk about sintering. Sintering is a very in-depth topic. We could probably spend hours talking about it. Let's just talk at a high level. What is the sintering process and what's encompassed part of that?
Yeah, so metal injection molding technology, we typically say our tolerance capability is about 0.5% of nominal. So over 1 inch, you can expect a tolerance band of plus or minus 5 thousandths. And then that tolerance that capability will decrease relatively with the size of the part, down to about 2 thousandths to 1.5 thousandths. So, there's a lot going on in sintering, and it's commonly asked, well, how are you that repeatable? And it's a number of things. So number one, we start out with a component that's injection molded, which is a precision manufacturing technology in itself. So the parts that we start with are highly repeatable to begin with.
So the feedstock that's used in the injection molding process is a combination of metal powders and polymers. Polymers, of course, helping the flow of the metal powder into the form that's created in the cavity of the mold. Once you get to the point of sintering, past that first stage of debind, our sintering, or at least our preferred method of sintering here, is vacuum sintering. Right. Typically from door closed to door open, that's about a 24-hour time period. Right. And it consists of multiple ramps and holds at different temperatures. The first being, the hold to remove the backbone binders.
Yep.
So with the feedstocks that we're working with, there's 2 different holds to remove the backbone binders. But then as it starts to ramp up to that final peak sintering temperature, the main idea or the main premise behind that is consolidation of those metal powders into a component that's almost fully dense. With that, you have diffusion occurring during the sintering process, both surface and volume diffusion. An example of that might be evaporation condensation for surface and plastic flow for volume diffusion. But that total hold at that peak temperature is what allows the consolidation into components that are typically 98% plus density for that given alloy system. Say when we're selecting the vacuum sintering process, or the let's call it the recipe, we call it, what goes into determining what that cycle is going to look like? The first thing is understanding what the backbone binders are, where their melting point is, so that we can remove them from the compact. But then the second thing is the composition of the material system you're working with and the metal powders themselves. That peak sintering temperature and the hold at that sintering temperature is what allows densification of that material. So when we're at that high temperature and deformations happening, in some cases that may be problematic. Are there ways for us to solve that issue?
Absolutely, especially with very complex geometries. So what's happening in sintering, we start with a part that is at its pre-sintered size, and throughout the sintering process, the metal powders are consolidating. The part is densifying. It's isotropically shrinking, and with especially complex geometries, that can be challenging. So what we do is we employ what we call furniture to make sure that the part is supported all the way through sintering.
Right.
So as you can imagine, once all of those binders are gone and you're left with just the metal powders, it's a very fragile part. Yeah. So it really needs to be supported all the way through sintering. So here at APG, we have a highly engineered method of designing and manufacturing our own sintering furniture, and we have the ability to create very complex geometries, probably more complex than you can create through other traditional furniture making technologies.
Right.
And we can do them very quickly and very cost effectively.
All right. Well, gentlemen, thank you for the insight. If you have a project that you would like us to consider, or you would like to do an educational event at your facility, you can reach out to us through our nicholscortlandinc.com website or the alphaprecisionpm.com website, and contact us through that. And we look forward to hearing from you soon.